now our setup is ready to go. We're currently in the drum position here with our twin cutter, so we need to move it into the rotor position. Now everything's loose here. My twin cutter is not locked, so I can slide it back and forth as well. I want to get it roughly centered. I want to get it pretty well centered because I don't want one bit sticking out a lot more than the other, okay? We want them roughly centered. We want to be equal and opposite, so our pressure across those bits is even. That'll give us a better surface finish. Okay, now I can go ahead, now that I'm roughly centered, I go ahead and lock this in place. So I drop my lock down here, grab my wrench, tighten this up, make sure it's tight. We don't want it flopping around on us, that would affect our surface finish. Now I can go ahead and feed the bits in. And you might think to yourself, well, we're gonna go ahead and make a cut now, but we're not. We're not gonna cut yet because we're not sure what kind of quality on the setup we have, right? You might think, well, I could put a dial indicator on this face and see if there's any runout in it. But what if that runout's in the rotor? I wouldn't know the difference between runout in my setup or runout in the rotor. So we do what we call our scratch test. And what we're gonna do is we're just gonna feed each of these bits in until they just make contact with the rotor while it's spinning. That'll leave a scratch in one spot. We'll move to a different diameter and we're gonna loosen everything up, tighten it back up again and do it again. If our setup is correct, we'll feed back in, scratch it again, and those two scratches will be in the same phase or in the same spot right next to each other. They'll basically be parallel around the rotor. So let's go ahead and do our scratch test now. So the first thing we're gonna do is we're gonna power up the lathe, and I'm gonna go ahead, feed in a little bit here. Got my locks undone. I'm gonna feed my bits in and just make contact with the rotor. Now I'll tell you, there's one disadvantage we have with using a rotor that's sitting here and not from a real car is I don't have a lot of run out in this, but we're gonna do the best we can and simulate this effect. So let me go ahead and just touch that. And we don't want to plunge into this deep, we want to just make contact because we're going to want to see where that scratch ends up on the rotor. Now in this case, you can tell I'm making a pretty continuous cut around, but let's go ahead and act like this is a warped rotor. Okay, now I'm going to feed in the other bit and we're going to do the same thing. Just going to run it in slowly until I just make contact. Okay. Now let's go ahead and back our bits away. Don't need to back them up very far. And we're going to stop the lathe and we're going to loosen up the workpiece here. I'm going to take off my nut and my spacer. And all I want to do is jumble things up. So I'm just going to pull this off. I'm going to spin my cone around a little bit, 180, mount everything back up. Why'd I do that? Well, I'm testing my setup. If everything's correct, I'm going to get exactly the same results with the second round of my scratch test, right? Tighten that up. Now let's go ahead and make the second cut. Now I need to move my bits away from the original cut, so I'm going to move them out, board a little bit here. Now we're going to start the lathe up. And we're going to bring them back in and do the same thing again. I'll feed in the bits on the outside. Just to make that scratch. Now I'm going to go to the other side and do the same thing. I'm going to feed this one in until it just makes contact. Now we can go ahead and shut the lathe off. We'll back our bits away, shut the lathe off, and see what we got. So now let's take a look at the results of our scratch test. What you'll see here are two rings that go around. Okay, now this rotor already had been cut, so there's essentially no run out in it. But what that gives us is two continuous rings that go all the way around. All right, so that's good. We had a perfect setup to start, we had a perfect setup in the finish, so we're good to go. In the real world, what you're most likely going to see is that there was run out in the rotor to start with. That's why you're machining them normally. And so what you'll end up with are scratches that may run for a few inches, they might run a little longer, whatever the case may be, but you want to see those two scratches very similar to each other. I don't want to see one scratch over here and one scratch over here. I want to see two scratches that run roughly parallel to each other. That's how we know we're ready to go. All right, so now we're all set to make our cut. So I'm going to turn the lathe on, the rotor starts spinning, and now I'm going to talk about our feed rate. So you notice I've got lots of speed options here. This is a much faster speed rate, 910. We can use that to make a coarse pass first. If we have a really rough looking rotor, we might choose to do that. Or we can slow things down in this one cut pass area and do it in a single cut. It's basically a preference issue. In this case, I know I've got a pretty good rotor. I'm going to do it in one pass, so I'm going to set it in the single cut pass window. Now we're going to go to our cross feed and bring our bits into position, roughly central on the rotor, and I'm going to feed them in. Now I'm using the digical option, so I'm going to feed these in just to where I make contact on the rotor on both of these. And then I'm going to reset them. All right, so now I know I've zeroed them out, and I'm going to run my bits in basically to the edge of where the braking surface is for the brake pads, okay? Now, if we had some rust rings here, this would be a good time to clean them off before we make the cut. We might take 2-3 passes depending on how bad those rust rings are. But what I'm going to do is I'm going to add 0.004 per side just by turning the dials here. So now we're going to go ahead and lock down the bits. Now before I start my feed, I'm always got to be worried about chatter. We don't want this rotor to start singing, so I'm going to use this device. What I'll do is I'm going to put that on, and I'm going to actually Velcro this around my twin cutter here, just to hold it in place so it doesn't go flying on me. And then we're going to go ahead and engage our feed into the drum position, into the disc position, excuse me, and start making our cut. So now when we come to the end of the cut here, our anti-chatter device is going to fall off, but that's okay. We've got it Velcroed on here so it won't go anywhere. Now we're all finished with our cut, so we can take our anti-chatter device off here, move our Velcro, shut the lathe off, and we're all finished.